Welcome to a lesson on null and alternative hypotheses. One job of a statistician is to make statistical inferences about populations based on samples taken from the population. Confidence intervals are one way to estimate a population parameter. Another way to make a statistical inference is to make a decision about a parameter. For example, let's say a car dealership advertises that its new truck gets 35 miles per gallon on average, or a tutoring service claims that its method of tutoring helps 90% of its students get an A or a B. Or a company says that women managers in their company earn an average of $60,000 per year. A statistician will make a decision about these claims, and this process is called hypothesis testing. A hypothesis test involves collecting data from a sample and evaluating the data. Then the statistician makes a decision as to whether or not there is sufficient evidence, based upon analysis of the data, to reject the null hypothesis. So the actual test begins by considering two hypotheses. They are called the null hypothesis and the alternative hypothesis. These hypotheses contain opposing viewpoints. We use a notation H sub 0 or H naught for the null hypothesis, which is a statement that the value of the population parameter is the same as the claimed value. In other words, the difference equals 0. Null indicates no change or no effect. The alternative hypothesis, indicated by H sub A or H sub 1, is a claim that the population parameter is different from the claimed value and is contradictory to H sub 0, the null hypothesis. It is the conclusion when the null hypothesis is rejected. Since the null and alternative hypotheses are contradictory, you must examine evidence to determine if you have enough evidence to reject the null hypothesis or not. The evidence is in the form of sample data. Looking at the table, notice how the mathematical symbols used for the null hypothesis are equals, greater than or equal to, or less than or equal to. For the alternative hypothesis, so H sub 0, the null hypothesis, always has a symbol with an equal in it. The alternative hypothesis never has a symbol with an equal in it. The choice of symbol depends on the wording of the hypothesis test. However, it is important to recognize that many researchers use equals in the null hypothesis, even with greater than or less than as the symbol in the alternative hypothesis. This practice is acceptable because we only make the decision to reject or not reject the null hypothesis. So in that case, you wouldn't see greater than or equal to or less than or equal to in the null hypothesis. Let's take a look at some examples. We want to test whether the mean GPA of students in American colleges is different from 2.0. State the null and alternative hypotheses. So we're trying to test to see whether the GPA is different from 2.0, which would be mu not equal to 2 or 2.0. So if it's false that mu doesn't equal 2.0, then mu does equal 2.0. We know the alternative hypothesis never has an equal symbol in it, and therefore the alternative hypothesis must be mu not equal to 2, which means the null hypothesis must be mu equals 2. And of course 2 and 2.0 are equivalent. Next, we want to test if college students take less than 5 years to graduate from college on average. Again, state the null and alternative hypotheses. So we're trying to test to see whether it takes less than 5 years, which should be mu less than 5. And if mu isn't less than 5, then mu is greater than or equal to 5. And again, the alternative hypothesis does not have an equal symbol in it, and therefore the alternative hypothesis is mu less than 5. And the null hypothesis does have an equal symbol in it, and therefore the null hypothesis is mu greater than or equal to 5. Just keep in mind, some researchers would just state this as mu equals 5. Next, on a driver's test, about 40% pass the test on the first try. We want to test if more than 40% pass on the first try. Because we have a percent here, we will use the variable p for the proportion. We're testing to see if more than 40% pass, which would be p greater than 40% as a decimal is 0.4. And if p is not greater than 0.4, we would have p less than or equal to 0.4. So again, the alternative hypothesis does not have an equal symbol in it, and therefore the alternative hypothesis is p greater than 0.4. The null hypothesis does have the equal symbol in it, and therefore the null hypothesis is p less than or equal to 0.4, or once again, some researchers would just state p equals 0.4. And for the last example, in an issue of U.S. News and World Report, an article on school standards stated that about half of all students in France, Germany, and Israel take advanced placement exams and a third pass. The same article stated that 6.6% of U.S. students take advanced placement exams and 4.4% pass. Test if the percent of U.S. students who take advanced placement exams is more than 6.6%. Well, more than 6.6% would be p greater than 0.066, and if p is not greater than 0.066, p is less than or equal to 0.066. So again, the alternative hypothesis would have to be p greater than 0.066, because we do not have an equal symbol in this inequality symbol. And the null hypothesis would be p less than or equal to 0.066, or some researchers would just use p equals 0.066. I hope you found this helpful.